Okay, here we go. So the only thing we have to do today is kind of wrap up the end of the section. And I think today is going to be some of the easiest thing that we do. And your homework is only like 4 or 5 questions for today. It's really short. There wasn't a lot of problems left that I needed to assign. All right, so let's just review a few things that we know about section 4.5. So first of all, a number that is not in the domain, a number that makes the bottom equal 0, that's not going to be a number in the domain of a rational function. Those numbers will become one of two things. They will either become a vertical asymptote or they will become a whole. Whatever number that is not in the domain that stays in the reduced version becomes a VA. Any number that cancels out in the reducing, that number who's not in the domain that canceled becomes your whole, or wholes. You can have more than one. All right? A rational function cannot cross over a VA. Guys, VAs, these vertical asymptotes, they literally are telling you X values where the graph cannot exist. So there will never be a graphable point for that X value. So the graph cannot exist there. So a VA is going to act like a brick wall that your graph will never go through. You're going to have a curve on one side of it, and then the curve will pick up on the other side of it. But it'll never pass through the vertical asymptote. It can't exist at that X value. All right? The graph of a rational function, the ones I assign you at least, you will either have an HA, a horizontal asymptote, or you will have an oblique asymptote, but you can't have both. All right, because they follow a rule. So either you'll have an HA, but no oblique, no slant, or you'll have an oblique or a slant, but not a horizontal. Okay, you'll have one or the other depending on the rules of the degrees. Okay, the graph of a rational function, guys, it can cross over an HA or an OA. They are not brick walls. There's no rule out there that says there isn't an X value in the domain that makes it equal the HA or the OA. So it's okay to cross them. So in our list of steps in the next section, we're always going to be looking to see, does our graph cross the HA or the OA? We're going to have to check for that. All right? So it never crosses the VA, but it can cross the other asymptotes. All right, so the only type of problems we have left in this section is they're going to give you an already graphed rational equation. All you got to do is pick off all the components. They're going to ask you to identify the domain, the range, the intercepts, if it has any, the HAs, if it has any, the oblique, if it has any, and the VAs. So guys, just got to look at these graphs. I'm going to pull all this information off of it, and everything's already there for us, all right? Let's see what we got. All right, I did put this on your Google Classroom. I hope you guys can see it from home. All right, but here we go. The first thing it says is to find the domain. All right, so guys, basically to find the domain, you're looking for the X values that are not in it. Who's not in the domain of this function? So to figure out who's in the domain, you would be looking for VAs because that would be a bad X value, and you'd be looking for a whole because that would be a bad X value. So let's see. I definitely have a vertical asymptote where X equals 2. So I have a VA where X equals 2. So that means 2 must be a bad guy. He must be a number that makes the bottom of this equation equal 0. So we don't want him in our domain. So obviously, right now, as far as the domain is concerned, X can't be 2. Now I'd be looking for any other VAs because there can be more than one vertical asymptote, but I don't see one. And then I'd be looking for a hole. I do not see. A hole would just be like an open circle that the graph passed through. All right? It's not a VA, but it's a point where the graph can't exist. All right? But I don't see any open circles on any of these curves. So there's no hole. So that means the only bad X value is 2. So if we put that domain in interval notation where X can't be 2, it looks like it can be any number from negative infinity to 2. And then from 2 to infinity. Everybody okay with that? Everybody good? All right, then it asks for the range. Well, the range are the Y values. What Y values live on this graph? Now remember, this graph is made up of 2 separate curves. So on this curve, the Y values are shooting all the way off to negative infinity. So they're coming from negative infinity all the way up to, well guys, it looks like I have an HA, a horizontal line. All right, I have an HA when Y is equal to 1. So unless it crosses it, which they're not showing us a cross, so we're going to assume it doesn't, It just means that the y values are going to get really, really close to becoming 1, but they don't actually become it. Same thing on this side. The y values, as x gets bigger, they're getting closer and closer and closer to becoming 1, but they don't become it because they don't show us across. So now this curve has a range from negative infinity to 1, but not including 1. Union, this curve picks up on the other side of y being 1 and then shoots off to infinity. So the only y value that doesn't live on this function's graph is the y value 1. Is everybody okay with that? Yeah? All right, let's go to the next piece. Now they want to know, does it have any intercepts? Let's do x-intercepts. Where does it cross over the x-axis? Remember, there can always be more than one x-intercept. It crosses the x-axis right here. When, oh, there could be more than one. When x is 0, so 0, 0, and I don't know if the homework is going to ask you to write it as an ordered pair or just the x value, so pay attention to the directions. All right, and then it doesn't cross over again, so that's our only x-intercept. When we look at the y-intercept, a function will only ever have one y-intercept, or else it wouldn't pass the vertical line test and be a function. It also looks like the only y-intercept is at 0. All right, what about HAs? Well, guys, we did notice that it has a horizontal asymptote when y is 1. Which means if there's an HA, then there couldn't possibly be an OA. It can't have both. And then the VA, if any, we already found it. The vertical asymptote is when x is 2. Nice and easy. You okay? Again, like I feel like this is probably the easiest thing we've done so far because everything's already there for us. We're just picking the information off of the graph. All right, let's try one more that looks like this, and then you guys are good to go. We're done with this section. All right? All right, here we go. So let's go back to the beginning. Domain. What is this guy's domain? Now, I don't know if you guys can see it, especially if you're at home and not looking at this, but there is dash marks right here and right there, which means the y-axis is acting as a vertical asymptote. I don't know if you guys can see that from home. All right? So the domain, we're looking for bad guys. We're looking for numbers where a VA existed, and we're looking for a hole. So right now, I have a VA when x is 0. So he must be a bad guy. He must make the bottom of the fraction equal 0. All right, and then again, I'm looking for any open circles that the curves pass through. I don't see any open circles on this curve, and I don't see any open circles on this curve. So since there's no hole, that means there were no bad guys that canceled. So the only bad number in this function's domain is 0. X just can't be 0, which would be negative infinity to 0, union 0 to infinity. And just make sure you use parentheses so that you're not including the 0. All right, let's do the range. All right, I'm going to do a little bit of a spoiler here. I hope you guys can notice that this one has a slant oblique asymptote, but not a horizontal. So whenever you have an oblique, the end behavior, the range, well, guys, on this curve, this end of the graph is going to follow this line, this asymptote. It's going to follow it all the way where? All the way to where y goes to negative infinity. And then this end of the graph is going to follow this VA all the way up to positive infinity. So normally when you have an OA, your range is all real numbers because the slant allows each end of the graph to go off to the infinities. So in calculus, a lot of times you find out that a rational function has an oblique asymptote. You're like, oh, now I know the limit does not exist, or the limit is infinity because it's going off to infinity on this side and negative infinity on that side. So that's kind of a clue you can use in calculus the minute you know there's an oblique asymptote involved. You know each end of the graph is shooting off to the infinities, okay? Same thing over here. This end of the graph is going to follow this VA all the way down to negative infinity, and this end of the graph is going to follow that oblique all the way off to positive infinity. So the range is all real numbers. Where an HA kind of acts like a wall sometimes, and it stops it from getting to those infinities. All right, now what do they want? They want the intercepts. I'm looking for where the graph crosses the x-axis. Well, it looks like I got one right there at -1, 0, or just -1, depending on how they want you to write your answer, and then another one at 1, 0. I'm like off camera there. All right, y-intercept. Guys, if you have a VA directly on the y-axis, that means your graph can't cross it. So you couldn't possibly have a y-intercept if your y-axis is acting like a brick wall. All right, and then last, in HA, VAs, and OA. Well, let's get the VA out of the way. We already said it's got a VA at x = 0. All right, and then there's no horizontal asymptote, but there's a slant, there's an oblique. So when you have to do here, this is probably the most annoying part about an oblique when they give it to you. Now what you're gonna have to do is you're gonna have to write an equation for this slanted line. So to write the equation of the oblique, you need 2 points that are on it. And this one passes through 0, 0, and it passes through, they gave you the point 1, 2. So again, this point, he's not a point from the rational function. He's not a point that one of these curves creates. They were just giving you a point on the OA to use as reference, okay? All right, so find your slope. Change in y over change in x, that's going to be -2 over -1. Oops. My slope is 2, and we already know my y-intercept is 0. So plug it into y = mx plus b and be done. Y = -2 times x plus 0 is your y-intercept, but we don't have to write that. So it's just y equals, oh guys, I'm an idiot. It's a +2. Sorry. Y = 2x. And you're done. There's your oblique asymptote. Okay? Does that feel easy enough? Everybody at home, does that feel pretty simple? Everybody okay?